Hello everyone, today I am going to teach you n number of methods to solve HCF and LCM. LCM stands for least common multiple and HCF stands for highest common factor. Come, let's solve problem. Find LCM of two numbers. So if in question they have given two numbers, then this is how you need to solve LCM. So the question is find LCM of 12 and 52. We need to solve it using prime factorization method. So I have to write both the numbers 12 and 52. We must always use only prime numbers and 1 is not a prime, so we should start from 2. 2 6 2 26. Again these both the numbers are factorizable by 2. So again I will take 2 3s 2 13s. Further it cannot be factorized using 2, so we can try 3 3 1s 13 isn't possible, so we'll write it as it is. Next 13 1s. So this is how we need to factorize it. So LCM of 12 and 52 is, we need to multiply all these numbers. So 2 into 2 into 3 into 13. So you'll get 156. So 156 is your LCM of 12 and 52. I hope it is clear. Next, find HCF of two numbers. I'll take the same number. So how to find HCF of 12 and 52? Here I'll teach you two different methods. You can use any method which is easier for you. So method 1 is, it is similar to this method. So we need to take prime factorization of 12 and 52. So again we'll start from the least number, that is 2 6 to 26. Again 2 3s and 13s. Now here 3 and 13 both cannot be factorized further using a same number. Thus we need to end our step here because we want only highest common factor or a multiple. Okay, so only we need to take 2 and 2, that is 2 into 2 is equal to 4. So this is our highest common multiple. The next method is, we need to do normal division. So here I will write the bigger number inside and we'll divide it by 12. Okay, so 12 4s are 48. Okay, so when we subtract it, we'll get remainder as 4. Further we need to take the divisor, that is 12, as our dividend. Further you have to do division. So 4 3s are 12. So now it is completely divisible. So the last number using which we divided becomes our HCF. So this is our HCF. So these are two methods using which you can solve HCF of two number. I'll teach you one more general method or a long method using which we can find LCM and HCF simultaneously. Okay, so this is a general method. All you need to do is separately factorize both the numbers, that is 12 separate and 52 separate. So 2 6 2 3s and 3 1s, and similarly here 2 26 2 13s and 13 1s. Okay, now when we need to find LCM, what we have to do is, now you can see here 2 and 2. So it is common in both the sides. So we need to write it only one time. Similarly 2 and 2, this is also common for the both the numbers. So again write it only one time. Then 3 and 13, these are only in the either side, so we can write it as it is. So we'll multiply this 2 into 2 into 3 into 13, that is 156. So you will get the same answer, 156. Now if you need to find HCF, we only need to take a number which is present in both the columns. So 2, 2, 2 and 2. So it will be 2 into 2, that is 4. So I hope these methods are clear. Now let's learn how to solve LCM and HCF of 3 or more numbers. So the question given here is find LCM and HCF of 10, 15 and 20. So the first method is we'll write all the 3 numbers 10, 15 and 20. Let's do the prime factorization. So 2 5s are 10. 15 it is not possible. So if it is not possible, we'll write the number as it is. 2 10s are. Further again you need to use 2. 5 as it is. 15 as it is. 2 5s are 10. Okay. Next we can use 3. 5 as it is. 3 5s are 15 and 5 as it is. Next prime number will be 5. 5 ones are 5 ones are 5 ones are. So our factorization is over. So these many numbers we got. So LCM of these 3 numbers will be 2 into 2 into 3 into 5. That is 60. So LCM is 60. Next, if you want to find HCF, same method, we'll write it once again 10, 15 and 20. So the HCF of 10, 15, 20 will be, so we need to choose a number which can equally divide 10, 15 and 20 at the same time. So it is not possible using 2 because in 2 table we do not have 15, and it is not possible by 3 because in 3 table also we do not have 10 and 20. So the only option left is 5. 5 2s are, 5 3s are and 5 4s are. Further also it is not possible because 2, 3, 4 are together not present in any of the table. So HCF of these 3 number will be 5. I hope this is clear. So the general method to find LCM and HCF of 3 numbers is just write down all the 3 numbers separately. We'll factorize them separately. 10, 15 and 20. Okay. So 2 5s are, 5 1s are, 3 5s are and 5 1s are, 2 10s are, 2 5s are and 5 1s are. Okay. So I think this prime factorization method is clear for you. Now what we have to do is we need to find LCM. So LCM of 10, 15 and 20 will be, which number is repeating in all the 3? 1, 2, 3. That is 5, 5 and 5 is common in all the 3. So we will write it only once. Again we can see that 2 and 2 is repeating in the 2 series, that is in 10 and 20. These also will write it only once. So 2. Remaining numbers we can write as it is. So there is 1 3 remaining and 1 2 remaining. So it is 5 into 2 into 3 into 2. That is again 60. So we will get the same answer as in the method 1. Then going to HCF of 10, 15 and 20. So we need to choose a number which is common in all the 3. So here is 5, here is 5 and here is 5. So there is only one number which is common in all the 3 numbers. So your HCF will be 5. I hope this method is clear for you. Next concept is LCM and HCF of a fraction. So if a fraction is given to you, how do you find LCM and HCF of the fraction? So the important formulas are LCM of fraction is given by LCM of the numerator, that is numerator of the fraction, whole divided by HCF of the denominators of the fraction. Similarly, if you want to find HCF of fractions, then we need to use the formula HCF of numerators whole divided by LCM of denominator. I will explain this formula using a problem. Let us take a problem. For example, let us choose the fractions as 3 by 5, 4 by 15 and 9 by 8. First, let us find LCM and HCF of these two numbers. This is the solution of your first formula. Okay. So, we will find LCM of the numerator. LCM of numerator. So, I will choose only the numerator terms. So, the numerator terms are 3, 4 and 9. I need to find LCM of these three numbers. We will start using 2. 3 is as it is. 2. 2s are 4. Then is 9 as it is. Again 2. 1s are 9 as it is. 3. 1s are 3. 3s are 9. So 1, 1, 1. So our factorization is completed. So LCM of numerator will be 2 into 2 into 3 into 3. That will be 36. I hope this is clear. Now we need to find HCF of denominator. So HCF of denominator will be, we'll write the denominator terms, that is 5, 15 and 8. So is there any number which can divide all the three equally? No, there is no such number. So if it is not possible to factorize all the three numbers at a time, then we need to take the number as 1. So our HCF will be 1. Let us substitute this in the formula. So the answer will be LCM of numerator is 36 divided by HCF of denominator will be 1. So the answer is 36. Okay, clear? Now moving on to the second formula, HCF of a fraction. Okay, so if we will take the same question. So HCF of 3 by 5, 4 by 15 and 9 by 8. Here we need to take HCF of numerators. Okay, so I'll write the numerator, that is 3, 4, 9. We need to find HCF of these three. Here also 3, 4, 9 commonly are not present in any of the numbers. So we can take it as 1. So your HCF is 1. Now coming to the LCM of denominators. We'll write all the denominators, that is 5, 15 and 8. We'll have to solve for LCM. So we'll start with 2, 5 as it is, 15 as it is, 2 4s is 8. Again 2, 15 as it is, 2 2s is 4. Again 2, 5 as it is, 15 as it is, 1s. Then 3, 5 and 5, 1. Finally we'll take 5, 1, 1, 1. So this is our LCM. So our LCM will be 2 into 2 into 2 into 3 into 5. So the answer will be 120. Okay, so we'll substitute in the formula. So the HCF of numerator is 1 whole divided by LCM of the denominator is 120. So our answer is 1 divided by 120. I hope these methods were clear, and for more related videos, Please like, share, subscribe my channel. Thank you.